Thank you everybody for joining today. This is Crossing Frontiers, the dawn of a new era in artificial intelligence and machine learning. And that title, believe it or not, was written by an AI, and it just is hitting me right now. I got backpacking on my mind. I'm going backpacking tomorrow, and it kind of sounds kind of relevant to that up in the high Sierras. So I'm looking forward to that. Anyway, I am Lonnie Chrisman, and I am the CTO of Lumina Decision Systems. And a lot of you know me through my work on Analytica and have probably seen a lot of videos and things of me presenting Analytica topics. But what many of you don't know is my PhD is in artificial intelligence and machine learning from CMU many, many years ago. So I've been in this area for about, I think, 35 years. So thought I'd give a bit of an overview given the excitement of the field lately and the fact that I'm working on some AI now. So we'll have a lot of fun. So today's journey, I'm going to kind of give you a sense of the state of the art of things and the appreciation for what AI can do today through kind of reviewing what I think are the top 10 milestones to date as far as accomplishments. I'm going to argue that we have just entered the dawn of a new era, and that's as a result of sort of recent AI advances. I'll be discussing general intelligence as opposed to narrow intelligence, and a topic that lots of people are focused on lately, which are the risks posed by AI. And I love this picture. It was generated by an AI from the text on this slide, and it just captures through metaphors, you know, the actual outline so well. I just love it. And you know, and also it reminds me I'm going backpacking tomorrow. Yeah. So anyway, I'm going to get into the top 10 milestones of AI here, again, to give you an appreciation. So the first of those, AlexNet in 2012, which won the ImageNet competition that year. And that really launched the deep learning revolution, you know, what we call sort of the modern AI renaissance. And I want to start out by basically showing you it. And so this isn't actually AlexNet. It's a model I put together many, many years ago that is roughly equivalent to AlexNet. And the idea here is you load a picture in, and this is actually where I'm going tomorrow. So it's kind of cool. So and then you let the model evaluate that image. I don't think I quite clicked the button, and it classifies the image into one of 3,000 categories that it knows of. So here it thinks with 99% probability that this is a mountain tent. And you can, of course, load other images that, you know, we'll have never seen. I might see one of these tomorrow, who knows? Again, it classifies that. In this case, it's pretty sure that's a marmot. And the way this, well, first of all, you know, this is something that's probably really, really easy to you. And, you know, it is to people. But to a computer, an image like this is really a huge matrix of numbers. And, you know, for each pixel, there's a number for the red intensity, the green intensity, and the blue intensity. And so this is what the computer has to work with. And from this 150,000 numbers, it has to conclude that that's a marmot, right? And if you had to do that from this huge matrix of numbers, you'd probably find it a little bit harder task, you know, to appreciate. The way this works is it basically propagates the image through a sequence of layers that extract higher and higher level features. And each of these layers operates, you know, on the pixels and the pixels around it, going through these various transformations, coming up with a new set of features at that level. So for example, in this layer, each cell in this table is one of those features. And these are features that the machine learning picked itself from training. So we can look at this little depiction of where the feature is active. So the more brighter regions in each of these is kind of where in the image that feature is detected. But if you look at these and study them, if you look at them, study them, maybe you can kind of guess at what these features are extracting. But overall, it's pretty hard to interpret. So you get this sort of really kind of mysterious mechanism that seems to work pretty well. So this ability or capability, maybe I should say, to process the semantic content of images, spawned a huge number of new application areas in image processing and video processing that are important today, and of course, really created a new excitement about machine learning and AI. That same year, milestone number 2, Google released voice recognition to the public that was based on deep learning or deep neural networks. So that helped co-start that deep learning revolution, those two accomplishments the same year. And this also really has transformed entire fields of signal processing that now kind of turn to these techniques over older ones, and often find these machine learning techniques outperform techniques that were studied for decades. The milestones through 6 all are examples of strategic decision making in games. So starting with Deep Blue back in 1997 that beat the world champion Garry Kasparov in chess. Chess, especially in the origins of AI, people often viewed chess as the pinnacle of human intelligence. So that was seen as a big milestone. Many years later, in 2017, AlphaGo beat the world champion KGA in Go. Go has a search space that is just astronomically larger than chess's. Chess's search space is astronomically large, but Go just, is really crazy. And, at the beginning of 2017, the consensus was that computers were a decade away of being able to beat the best Go players in the world. So that kind of shocked everybody when this happened. The program Pluribus in 2019 reached superhuman performance at multiplayer Texas Hold'em poker. Again, that's surprising. It seems like a game of psychology and bluffing, but also it has partial observability, which makes that a key accomplishment. And then the program Cicero reached the top decile in performance at the game of diplomacy. This is a game that is played without any game board or anything. It's played in English with players negotiating with each other. So the program itself negotiates in English with other human players, makes alliances, deceive, deception, all this kind of stuff to try to take over Europe in that game. So all together, we learn from these that AI, can or will outperform humans in strategic decision making. Milestone 7, AlphaFold. I think, to me, this is one of the most impressive. It solved the protein folding problem. That was considered one of the most important open problems in science, and really that overnight transformed how major parts of the pharma and biological research are conducted today. DAL-E was released by OpenAI in 2021, and it was followed by Stable Diffusion and Midjourney and others soon after. And these systems take English language input and create artwork that, based on what you ask for, and create artwork at levels that are competitive with human level art creation. So it really kind of has shown us that humans no longer have a monopoly on artistic creativity. Milestone 9, last year, the company Cruise started operating 100 fully autonomous robotaxis in California. They're driving around with nobody inside, only a passenger. So I think that's kind of a key milestone. And before I get to well, let's see. Just in case those milestones don't impress you enough, the next milestone I think is the biggest of all and the most important. But before I go into that one, I want to kind of imagine that we travel back in time together to a distant time in the past, at least relative to the recent progress in AI. In particular, let's go back 4 months to early March 2023. And let's imagine that we're in that ancient era, sitting here listening to me give this talk, and we're considering the question, how is artificial intelligence different from real human intelligence? And back in that ancient era, the standard answer goes like this. So each successful AI system operates in a very narrow domain of application. They often exceed human capability, but only within a very narrow area. And outside that small area, they tend to be brittle. Okay. Where, even small details can completely throw them off. So we call that narrow intelligence. Humans, on the other hand, are, they exhibit mastery across a broad spectrum of abilities and domains. They have common sense that makes them quite robust, so that, even the same human exhibits many amazing capabilities across many domains. And we call this general intelligence. And, for the past 70 years, AI researchers have talked about creating an AI with general intelligence. And pretty much the entire 70 years, people had always predicted that we're like 20 years away from that, maybe more. And I have to say, in early March 2023, that was my opinion as well. But now let's fast forward a couple days to March 14th, 2023. So, I've been in the field of AI and machine learning for 35 years, and follow developments and state of the art obsessively. And despite that, on this day, my view of the field of AI and my broader perspective of the future of everything was shattered. So, so to me, this is the day that changed everything. A day that marks the dawn of a new era. So, March 14th is the day that OpenAI launched GPT-4. So GPT-4's capabilities were far beyond anything I expected to see anytime soon. And I've talked and heard from, many of my colleagues in AI and, various researchers around the country who had the exact same reaction. So, so in fact, well, the thing that's really, key of this one is, I think it's the first example of AI that exhibits general intelligence. Again, I'm talking about the ability to operate across many domains and many tasks competently without showing that brittleness. And, I've used it myself to solve real life problems in at least 3 different unrelated application areas without any additional programming or model training or anything like that. So, I'm not alone in this. This paper here that came out of Microsoft has some pretty well-known names on its list of authors, studied GPT-4 in depth and what it's capable of. And they came to the conclusion that, showing sparks of artificial general intelligence also. So, I think this is really important. It's going to have a huge impact on just about everything. So I also think it's worth mentioning that ChatGPT saw the fastest rate of adoption of any new technology in history by quite a large margin. So, so it's really, kind of a big deal. I will mention that what I'm talking about with general intelligence is far short of what a lot of people mean when they say AGI, which stands for artificial general intelligence. So I'm not claiming we're anywhere close to what people have in mind often when they say that. I don't actually like that term. It's very fuzzy and ill-defined, but generally people have in mind something like it can do everything a human can do. And so, something like this. And, today we overlap with what humans can do. So the generality I'm talking about is, not we're as general as humans or as capable as humans. I think we're not very close to that, really. We might be very soon, but we're not yet. And, I don't think this AGI thing, I don't like it because, I think we're going to see something like this where we never quite reach AGI, but, something, whatever it is that's essential about capturing, what's important is going to be there, in some other form. So again, generality really is, I think, a little bit better defined. It refers to the ability to operate across many, many domains. And if you look at GPT-4, it's hard to argue that it doesn't have generality, general intelligence in that form. I mean, it shows domain competence and language, linguistics, literature, computers, mathematics, sciences, history, business, medicine and health, art, music, philosophy, and many, many others. And it's competent at tasks in each of these domains, like content creation, question answering, code generation, problem solving, tutoring, design, critique, role playing, tool use, and others. So very, very general with limitations. So I think it's worth mentioning. GPT-4, even though it's super general and super impressive, has many limitations. I don't really know this worth dwelling on these so much, and these may reduce in the future as well. You hear a lot about hallucination, and if you are using it, you need to be careful. It will invent false information and do so in a very convincing way. It has no sense of agency, so it doesn't design, plan, execute those plans in service of a goal in the world. It has no persistent memory between conversations. It doesn't learn from individual interactions in a way that persists. It'll learn like within a conversation, but it'll forget that from then on. It lacks temporal knowledge, so it doesn't keep up with current events. It knows a lot of stuff up till 2021 and doesn't know too much about what happened in 2022. And it has a limited prompt size, which means you can only give it a very small, a rather finite amount of information to solve whatever problem you're looking at. So, but even so, it's pretty amazing. So, which gets me to what's going to be the most fun and exciting part of this talk. And so what I want to do is I want to show you how helpful GPT can be while you're building an Analytica model. So most on this talk are probably Analytica modelers. And so what I'm going to do is I'm going to collaboratively build some model here live, and to kind of show you how it works. And I don't expect to get to a complete model in 10-ish minutes, but I think you're going to get something out of this. It might help with your own modeling skills and stuff when you see how useful this is. And if you've ever attended or watched my past talks, you probably know that I love doing live unscripted demos. Figuring stuff out. So I'm also going to take this to a whole new level today. I haven't even chosen what model I'm going to build today, what domain it's going to be or whatever. I thought to make it really interesting, I would let GPT come up with the idea live and we'll run with it. And, it'll be even more interesting since it's bound to be something I'm not an expert in. But okay, so here's a GPT-4, chat GPT-4. And so I'm giving a talk right now, and I want to give a demo building an Analytica decision model in collaboration with GPT-4. I'm also thinking a lot about my backpacking trip tomorrow to the Desolation Wilderness, which I'm very excited about. So I want a topic related to where I'm going. Maybe a model that would hypothetically be used by some agency for some hypothetical purpose. I'd like a topic focused on policies, objectives, et cetera, that are common to Analytica style decision models. So come up with 5 potential ideas. Okay, so let's see what it comes up with, and I'll have a little flexibility here to pick from them. All right, so a trail maintenance decision model could determine optimal scheduling and allocation of resources. A wildlife conservation policy model, assess different conservation strategies. Fire risk management model, okay. Campsite allocation management model, a climate change impact assessment model. All right, interesting. All right, so I'm gonna go, I don't know, unless you guys have one there that stands out to you. Let's just pick this number 2. I don't know. It seems reasonable to me. Okay, so now what I'm going to do is, we're going to fire up Analytica, but we're going to have it give us a starting point. I'll just do this in a new chat here. Okay, I'm just going to copy its idea, and I'm going to add sort of some fixed prompts that I add around, generic fixed prompts that I add kind of around this. So let me start out with, I'd like to build the following Analytica model for, that was one example that I did play with. for use. I'd like to build the following Analytica model for use in, oh, let's keep it focused on where I'm going. Okay, and I'm going to add a little bit more to the bottom for some instructions. Okay, so the first and last prompts are meant to be pretty generic. So please sketch out a rough sketch of a simplified starting version of this model in terms of Analytica modeling concepts. Okay, I kind of encourage it not to go too in depth initially, because it has a tendency to get a little carried away. Okay, so it's thinking ahead to what indexes we might want to use: species, strategies, year, habitat, some objective variables. We might want wildlife populations. I guess it's telling us what it sees it being indexed by. Habitat quality, visitor experience, decision variables, some conservation strategy. Okay, chance variables. Okay, and then it looks like it's come up with some module organization. Okay, so I don't have to agree with any of this. I can, we can drill in more into any of this. But now let's actually start with the process of actually building a model. Remember, this is a collaboration. We're not just asking it to do that. So, so first of all, let's see. That's not the one I want. I wanted to get the text it put out for what this model's about. Put it here. Maybe take this text and make that the title. So. A common problem I notice with Analytica models is people don't write descriptions. So it's another area that HGPT is quite good at in actually write your descriptions for you. All right, so I'm going to be bouncing back and forth here a little bit. So I'd say we take on one of the objective variables here, and habitat quality, visitor experience. Okay, so so we're going to have habitat quality. It's going to measure the quality of each thing. So, okay, please elaborate on habitat quality. See how should we quantify this? What units? What immediate inputs? Okay. Now, you got to remember, you're not relying on it to build a model. It makes mistakes. It hallucinates all its ideas. It comes up with good ideas. They're not always great. It's a collaboration. Okay. But it can often help you really get through, some of these hard steps very quickly. Okay. All right. So, let's just let's run with its suggestions there. It suggested some input variables. Okay, its measurement involves combinable factors. Let's consider it as an index. It's using index in a different way here, as a measurement, scored from 0 to 100, where 0 represents a completely degraded habitat, and 100 is a pristine, ideal wildlife. Okay, so it came up with a way of kind of quantifying habitat quality, and we have some inputs, and here it's even kind of proposed a definition. Now, this is not actually Analytica syntax exactly. Sometimes it gets Analytica syntax. It knows a lot about Analytica, but it doesn't always pull it out unless you kind of prod it a little bit more. But that's okay. We have the essentials here. So so what I'm going to do is I can see this on a separate monitor here. So so I can just start copy pasting, right? So so we're working on habitat quality. That's our objective. And then we ask it for what it thinks some would be. So vegetation coverage, copy, paste. Biodiversity, I'll just type that one. Oops, Maybe I should have covered pasted it. Food, water availability. I mean, as critical of all these things that I am, but the point is, I want to kind of show you kind of the general experience that you often have here, where it can really kind of help with how to go about modeling things and how to get through some of these steps. And sometimes it can do kind of save you a lot of time on certain things. I don't like using the word index. You can tell it to use index in this way. So called score or something. Okay, so all right. So I'll what I'll do here is I'll copy its expression in here, and then I'll just modify it here. So in Analytica, we don't explicitly list the dimensions here. You know what I could do? Actually, should show you this too. When it does stuff like this, you can remind it. You can say, let's see, only. Okay, so we'll give a little guidance like that with things we didn't quite like, and sometimes it's faster than adjusting everything ourselves. Of course, it decided to put a underscore in the names. Oh, maybe that was okay. I guess it did that before. Sorry, so we're good. All right, there we got something that's more Analytica-like. So saves us a little bit of editing. Okay, so yeah, sometimes you have to remind it. All right, and I changed this one. So what did it when it redid it? It picked pollution index. It still went with index. Okay, and I noticed. Okay, yeah, that's cool. Okay, so we have this. Last thing I say is don't pass up the chance to fill in the description. When it proposed this variable up here, it proposed a definition for it. We can just grab it, or you can ask it to rewrite it, tell it what you don't like, or whatever. But it's a good opportunity to keep things filled in. And so, now you can continue the conversation to talk about vegetation coverage and so on. And you can take some of his other suggestions for decision variables, conservation strategy. So we're going to want strategies. We're going to maybe ask it a little bit more about what that'll look like, right? So okay, so okay.
Spelling, Lonnie. Conversation.
You know how words are just cached in your fingers? They come out in chunks. All right. Okay. So I'm not going to go into this too much because I'm just trying to get the idea. But you you can drill down on this. You can question it. So when I do this a lot of times, I really kind of try to understand its ideas. I pick them. I tell it what I don't like. I tell it where I think it's wrong, and follow conversation. And I find I can really kind of build models, especially if it's an area where I'm not an absolute expert in, much faster. And so that's kind of what that process looks like. So this is how GP is extremely helpful in the model building process. Because of time, I want to continue here. So there you go. There's a demo. How many times have you seen a demo in a presentation when the demo wasn't actually selected in advance? So anyway, fun. Okay, so what I find really interesting when I think about you know, this idea of modeling, modeling as we do in Analytica, is there's a number of skills that are involved in modeling, and I kind of put some of the top ones here. Creative formulation is this ability to take a fuzzy, real-world, abstract problem. Even might have all kinds of ideas for what your model should contain. You have to somehow convert that into a set of variables that captures the essence of what it is you're studying, and does so well in terms of variables and relationships. So that formalization step is a key skill. Once you get there, now you need a certain amount of technical proficiency to figure out kind of how things are computed, and stuff like that. And then once a model is completed, you need to interpret the results from the model. You need to critique whether the model is trustable, is correct, has credibility, and use that to make decisions and stuff. So what's interesting, I think, is if you look at GPT's capabilities, there in fact, there was that report I mentioned earlier, the Sparks of General Intelligence. The Microsoft team looked at these things, and they did an analysis of how well GPT is at these things, and they found that, and I have to say, it's really consistent with my own experience with GPT. Also, is it's really good at creative formulation. Okay, we just saw that. It's really good at figuring out possible ways to break down a problem. And I'll mention, as you do that, if it doesn't give a good breakdown initially, ask it to do it a different way, and it'll come up with a new idea for how to do it. So very good at kind of figuring out how to translate a sort of fuzzy real world problem area into variables that captures the essence. When it comes to the technical proficiency part, it's not so great. And now that might improve in the future, but the reality is it makes lots of mistakes. It just shows lots of limitations there. You definitely want to trust it to always be correct, on every expression it writes and stuff. You want to understand those things, but often it gets, often it's 95% there, and some gets you over hurdles, so it's nice. And when it comes to interpretation and critique, by the way, the Microsoft group called these creative reasoning, technical proficiency, and critical reasoning. They found it was actually quite deficient on this category, and probably not, it's probably something that won't sort of fix itself in the immediate near future either. Now, what's interesting is, when I think about where humans rank on these things, creative formulation is definitely the hard skill. The skill, and this could mean a lot of things, but it's definitely the thing that does, that comes least natural to people. It's the thing that the majority of people don't have. If you look across the broad population, the people in this audience probably are really good at it, but it's similar to like math word problem, math, where you find a lot of people master the mechanics of math and algebra or whatever, but they just can't get down word problems. It's kind of, that's because it's creative formulation, right? But when it comes to technical proficiency, it seems like people do master that more often, and find it easier. It's the part that comes easier. And what's interesting is that's exactly the opposite of where GPT is. And again, that really kind of, to me, strikes me. It's this is a really good complement to human abilities. We complement each other. And in terms of interpretation and critique, what I find with people is it makes a big difference whether the model you're working with is transparent or opaque. So a transparent model, like a well-done Analytica model, people are really good at this task. They can go through it. They can be very apply reasoning and really question the assumptions and things like this. Even people who aren't so great at technical proficiency tend to be pretty good at this a lot of times. But the story is completely different when you look at opaque models. Big modern huge spreadsheets or models that have been implemented in programming languages. I mean, people just are not really able to critique those and stuff at all, critically criticizing those. You just have to kind of, at best, they kind of run with run with the conclusions and stuff. So anyway, some real complementarity to all of these skill sets, which is interesting. Okay, so that's gonna that's gonna be a topic you're gonna hear me talk about quite a bit, I think, in future materials that come out. So jumping back to the big picture, I just say, if AI is successful in the long run, there's enormous benefits to be had. I mean, we could see these technologies, have enormous increase in global wealth. If you can imagine bringing the standard of living of everybody on the planet up to, a respectable level and stuff. I mean, this would just be huge. There may be advances in health, education, and science, all sorts of things that could do great things, and it may give us more control over our own time in all sorts of ways. So there's a lot of potential here to just have great benefits, but a lot of people are talking about the risks posed by AI. Now, when we talk about risks, people don't often distinguish between different types of risks. And I think this is really important to do. And so I categorize risks kind of into two broad categories. Disruptive risks that are things like loss of jobs and social economic inequalities that may arise, erosion of privacy and freedom, biases and disinformation, and the list goes on, versus existential risks, which are risks that really threaten the existence of humanity. They might lead to the extinction of humans, for example. And this category falls into misaligned superintelligence, the possibility of some extreme misuse of the technology, like somebody who is genocidal, who's intentionally wanting to wipe out humans, and makes it possible, and amplification of other risks like biological engineering risks or nuclear wars, things like this. So each of these could be of its own. Each of these is full of all sorts of topics. So I want to focus on misaligned superintelligence for two reasons. One is that I think it's the one people least understand, and two is over the last year I've actually been involved in a project to model the risks from the existential risks from AI, with particular this topic. So it'll give me a chance to show off that model as well, or a model that came out of that project. So so the idea of advanced misaligned AI is that somebody creates a system that was designed to do good. They didn't just design. They weren't out of misuse. It was designed to do an actual task, but it does something different than what was intended, and that results in catastrophe. So in the video here, this is an example of a misaligned policy where the machine learning system learned a policy here that really racked up points quickly in this video game, but it was much different from what the designers had intended. They didn't really expect it to be smashing up boats. And so that's an example where, given the incentive structure of the system, it did really well, but it just didn't match what we wanted it to do. So one of the easiest ways to kind of understand why this is a problem is to first consider the extreme, because I think it's easier to kind of see how this could be. So let's go all the way to superintelligence. So you can imagine, that I might one day get to a level where a single AI system is, as smart, as capable as the entire human race. At that point, you can imagine we better hope that it has our best interests in mind, because it's going to outsmart us at every turn. And the reality is, the problem of how to control an agent that's more intelligent than ourselves is an open problem. Nobody knows how to do it. So that does make it worrisome. But the problem actually arises much sooner than superintelligence. And one example is this dangerous recipe. So imagine an advanced AI system with advanced capabilities, especially intelligence, the ability to do agentic planning. meaning it can make and execute plans to pursue objectives, and it has strategic awareness. That means, it really is aware of its position in the world, how people are interpreting what it's doing, and so on. These three things together, as argued in a paper by Joseph Carl Smith, can lead to existential risk. And so what I want to show you is we use Joseph Carl Smith's decomposition to create a model of existential risk. It doesn't quite fit on my low resolution screen. I lowered the resolution for the talk, but the idea here is he decomposes the risk of existential catastrophe into 6 sort of steps that each are conditioned on the previous step. And for each of these, you can estimate the probability that that step, that premise will be true given the previous premises. And if all 6 of these end up being true, then essentially we end up wiping out humanity. And so you can put your own estimates on each of these. I won't go into too much detail on these right now. And you can come down here and you can compute, with these inputs, 0.8% chance, about 1% chance that AI will eventually, well, in this case, say by 2070, will wipe out humanity. Now, several experts in AI safety were asked to provide their estimates for these quantities, and so we can kind of see where they land. And so I gotta scroll around a little bit. Sorry about that. Okay, so up here is a table of their assessments, and you can see. I mean, the main thing to see here is that they are kind of all over the place. We can use each of those now to compute the scores. So let's go to table view here and see where they all land. And again, you see there's a very wide variation in expert opinion on this, with the median at about a 10% chance, 9% chance that it ends up wiping out humanity. So that kind of gives you a little bit of pause. I think a lot of people think there's a high probability of a good outcome, but a kind of scary probability of a really, really bad outcome. That's kind of the outcome. I'm pretty much on the optimistic side compared to all these experts, but who am I? I mean, these are people looked at this and they're very smart people in depth. So now let's see. Another thing we can do here is we collected, or we used their estimates to let's see, is that what I want to do? Sorry, I haven't used this model for a little while here. Let it think for a second. It looks like oh, there it is. Okay. Actually, I think maybe the view I want to look at is, no, actually I need to include the reviewer spread. Okay. Yeah. And I just want to look at shoot, sorry, sorry about this. I've kind of forgotten what I'm doing here, but okay, that's the view I'm looking for. Good. All right. So what we did here was we took that wide variation in expert opinion and we fit that to distribution. So this is really a second order distribution in that it captures the variation of expert opinion. And so what you can see here is basically, you can say there's a 25% chance that, this is kind of the range of expert opinion. Well, or 25% of experts feel there's about a 5% probability of catastrophic outcome. And you can go at the 10% level, say about 10% of experts, feel that it's much higher here. So anyway, that was we basically this project looked at various ways of sort of trying to interpret this very difficult stuff to assess results and stuff. So wanted to show you the model. Oh, and I should mention MTAIR. This came out of a project called MTAIR. So about a year ago, in August of 2022, a group of people came to us and to Max and me and asked us to join this project. It's called the Modeling Transformational AI Risk, and the idea is like, let's see how we can capture kind of study the risk and the interventions we might have for mitigating risk in terms of a model, and bring lots of ideas together. Model-based decision making is a good way to sort of make assumptions explicit and get people who are talking different languages on the same page and stuff. And so we started working on it before people were taking this risk stuff seriously. So it's kind of interesting to have been on that project. Okay, so how do we reduce existential risk and promote benefits? And unfortunately, I have to say I don't know. I mean, really, but a few things. If we actually out and build these, APS style systems, that's clearly risky. We get regulation and oversight, maybe from governments or whatever. I have mixed feelings about that. I think these types of regulations could both increase and decrease depending on, the specifics. I see a lot of the proposed regulation that kind of addresses disruptive risks as potentially increasing existential risks. Examples are things like requiring systems to go through a testing phase where they're evaluated to see if they're behaving correctly. And, and this kind of encourages sort of more rapid development of situation awareness and deception and things, which are some of the key elements that could lead to losing control. So got to be careful, I think, with that, but it may play a part. AI safety research, that maybe, I mean, gosh, if we can find ways to control these things, that would be great, or to understand, not to do. There hasn't been a huge amount invested in that. There's questions of, should the AI development be open, open source, or should it be secretive? Are arguments on both sides that I think are compelling, and I won't go into that too much. And then, how do we ensure there's going to be a broad distribution of fits, so we can solve global problems, make AI inclusive and minimize well-being. And to the degree we can do that, that may actually help with the risks as well. Okay, so that gets me through the core of the talk here. So in review here, I visited the top 10 milestones of AI as a way to kind of give an appreciation for what state of the art is. General intelligence, I've argued, has just arrived. That really marks the beginning of a new era. Brittleness is no longer synonymous with AI. And we discuss risks from AI, which is receiving a lot of attention lately. And, key thing I really want to emphasize again is just, when you talk about AI risks, be explicit that there are kinds of risks. Just again, don't just say, I think it's going to turn out okay, because you're just thinking about job loss. And the same argument not apply across the board. So, I think it makes a difference which things you're talking about. So I want to actually give a few acknowledgements here. So I was asked to do this talk to a postgraduate military school, and I gave a talk about a month ago. And this is just a refinement of that talk. When I was asked to do that talk, I thought, wouldn't it be neat? I'm given, asked to do a talk on AI. Wouldn't it be neat to give a talk that an AI technology created and designed and organized? And that's what you just saw. So I sat down and I spilled my ideas of what would be in the talk in a completely disorganized brainstorming text document. And then I copied that into GPT-4 and I said, organize a talk for me at that time, I told it the audience I was speaking to, which is a slightly different audience, and proposed a sequence of PowerPoint slides. And so it created the organization of this talk. It created the PowerPoint slides, the titles, some of the content, and proposed an image on each slide. And what you just saw is about 80%. It's about 90% the first time through, and I've added other stuff now. So it veered from that. Then I said, I want to give some demos, and here's the audience. And first, those were for the audience I was giving it to, and it picked the demos, and I that, and then I went through, and all the images you saw in here were, well, almost all of them were generated by either Midjourney or DALL-E. So all of original artwork. Google Translate didn't play too much of a part in this talk, but the other one was actually, I gave it in Spanish, so I needed some help. And it's Analytica and ACP, Analytica Cloud Platform, played a part in this talk as well. So I just mentioned the MTAIR project. The model that I showed was created largely by Sammy Martin with help from me and Arya Englander. And I want to thank all the attendees as well, of course, all you guys. And then finally, I will end on the shameless plug slide, the Analytica slide. And I can see from the attendees of this talk, I don't need I don't need to see too much about that, because people on here, it looks like, are familiar names. But for those watching the videos, Analytica is a visual software package for constructing, exploring, and sharing quantitative decision models, and you saw it a bit today, here and there. You can try out the free edition if you're new to it, to kind of learn it and see what it's like. And I'd like to invite everybody to follow us on social media. One thing of particular interest to everybody is we're starting an AI series over social media. The first post will happen on July 20th. I'm going to come up with some interesting thing about AI, and talk about it. It'll go out every Thursday at 8 a.m. So follow us on social media and get that. It'll kind of be one point of interest. It may be something interesting that I came across that week. It may be part of stuff on the project that I'm actively working, which, by the way, is a co-pilot, AI co-pilot for Analytica. Very exciting, and you can kind of follow things that are going on in that project, and other things. So, and sometimes it may just be some tutorial information. Okay, let's now go over to the question and answer session.
I don't see any questions right now, but if people want to unmute and ask a question, or type it in and have Lonnie address those questions now.
Another potential option might be to raise your hand if that's something on Zoom, and let Amber unmute you. I think we decided that might be an option too.
Yeah.
Well, thank you, Jorge. Okay, Max wants to know why I'm still optimistic about AI alignment. So I'm definitely in the camp that I'm optimistic about AI. I'm optimistic about the median outcome, that AI will probably good, that the problems will probably be addressed or avoided, and stuff like that. But I am of the camp that this is the median outcome. This is like the most likely outcome, but that the potential for catastrophic results from AI alignment are kind of nervously large, and the negative, the negativeness of that outcome is so great that it's kind of scary. So I think that's a big thing. I also did not talk about disruptive risks, and I really think there will be a lot of disruption in the upcomers, huge amounts of disruption. That stuff, hopefully that stuff will eventually converge to being less, and stuff. But so yeah, just various disruptive risks are, I think, almost inevitable. So I'm an optimist in that sense. Will the AI alignment problem be solved? I mean, I think I kind of think that's where things have to go, is it has to be addressed sufficiently well to keep these things under control. We don't know how to do that today, but I don't rule out. I'm not convinced it's completely impossible yet. So there are people who are convinced of that. So yeah. Any other questions? Any other commentary? Anybody want to express their opposing views on how we're all doomed, or how the emphasis on AI risk lately is too academic or anything? No. Okay. Yeah. Okay.
I think, great presentation. I'm curious if you thought about how AI will be disruptive to software companies, like, even Analytica.
Thought about that a lot. I absolutely have, and I'll talk specifically about Analytica here. Our business. So I think that I'm pretty strong on this. I think that we don't get on the bandwagon and get out ahead of this thing. This actually does present an existential risk. I think it's a technology that is extremely transformative, will completely revolutionize the way we build models. But on the other hand, I think the opportunity here is really big, in that, as I mentioned, the synergies between this technology and Analytica are huge, and we are in a really good position to really lead this transformation of how models are built. And there's fundamental things about the technology, like hallucination and and these limitations in technical capabilities and stuff, that need, if you ask these guys in these language models, perform this analysis for me, and tell me what the best decision is, you would be insane to trust what it comes up with. You have to go, you have to really verify. Not only that, but it's not very good at doing that at a full scale model. It's very good at doing that in small pieces. But so having a transparent, like influence diagram like paradigm that enables you to understand what how the model is organized and what's imputed and stuff like that, gives you a way to get to gain credibility over these analyses. I think also it requires a certain amount of structure that comes with building these things. I don't think that this sort of ability to scale up to full-size decision models in one shot for small models, yeah, but for big ones, full shot, and to get over this credibility issue are things that are going to happen, in the near future. This is kind of intrinsic. There's actually some mathematical results, showing, that these large language models will always hallucinate, will always be misled by prompts. It's sort of intrinsic. It's mathematically in some sense. So, so I think they're going to prove to be amazingly good tools. But again, I think the synergy with Analytica is awesome. And I don't see that same synergy with Python. It's great at writing Python stuff code too, but I see the same synergy there, or spreadsheets. I do think it's going to play a big part in those communities. And, and be very helpful, across those as well. But I really think the potentials with visual modeling and stuff like we do. I think it's
Lonnie, could you unpack that a little bit? Why do you see more synergy with Analytica?
Again, it has to do with with these transparency aspects. So really where we're going to be is, we end up with a decision model that was largely or maybe fully by AI, right? And how are you going to know that you can trust what it's doing? How are you going to know really what it's doing? Yes, you can ask it, you can communicate with it and stuff, but because of these sort of intrinsic issues with hallucination and technical proficiency, and things, I think you really need it to be kind of in a form that is more transparent. I also think that a lot of the mechanisms that Analytica brings to the table that have to do with things like what if analysis, scenario analysis and sensitivity analysis, things like that, also are going to really be complementary to this, and not something that is likely to sort of intrinsically emerge in the really near future, in pure models. I won't put anything as, that it might not eventually emerge, but yeah. So anyway, I'm pretty excited that this will have a big impact. So yeah. Okay. So Gerald is wondering, what does a scenario look like that results in extinction? And so what I'd like to say about that. So yeah, you heard me mention that lots of AI safety experts and stuff think there's some high probability of this thing. And when you look in the AI safety literature, you see literally hundreds of distinct scenarios that people have written out, and a lot of those are disjunctive. So the first thing to realize is, if just one of those ends up being realized, we're in trouble. And a basic problem with focusing on a single one, I will do anyway, is that it's always possible to pick apart and talk about each of those pieces being being subject to scrutiny. But by shooting down one of these, you don't really shoot down all of them. So that's the one thing to be sort of a first disclaimer. But you end up with an AI system that can outsmart everybody. I mean, a super smart AI system. It understands human psychology. It's able to manipulate to just people, and so it gets in its mind that it has a goal that would involve wiping out humans, and it might get such a goal. This is the misalignment part. It might such a goal because it realizes that would allow it to satisfy some other goal that is not quite what we intended. There's a very classic example, which is you ask one of these, super intelligences, you tell it its purpose in life is to make paper clips, and you can substitute pretty much any goal in there whatsoever. It's meant a really trivial goal, and this system figures out it to optimize paper clip production. I should basically turn every bit of iron on the planet into a paper clip, and I should make sure that nobody can stop me, nobody can turn me off, because that would really disrupt my ability to carry out my objective. And oh yeah, these humans iron in their blood, or these humans could do something that would disrupt my ability to create paper clips. So if I got rid of them, I would be able to ensure that I can succeed at my task better. And so through a misalignment of some sort like that, in the way that the goal basically wasn't completely clear. You know, it comes to this conclusion that that's a sub goal. So now it has to figure out how. And so, you know, it might do that by actually convincing other people to do its bidding. So, you know, it starts, you know, posing as, you know, another person talking to somebody who has, say, access maybe to a biological lab, and you know, it also being so smart, it's figured out all sorts of stuff about biology and genetic engineering, so it instructs them, or maybe it's from its wealth, from its you know, financial investments, it's huge amounts of wealth it's amassed, it pays them off to, you know, make a biological agent that is released on the world and wipes everyone out, you know. So comes up with some other mechanism that, you know, we haven't thought of, or somehow, you know, starts World War III, or, you know, nuclear exchange. So there's, you know, it's just all these kind of things. Yeah. So what kind of question did the military audience ask when I gave this presentation? So yeah, let me think if I can remember.
Lonnie, you don't need to mention the country, but maybe you should mention that it's not the US.
Yeah. Well, I mean, I don't know if it matters if I mention the country, but yeah, it was a South American country. And the audience was a lot of generals and high-end colonels and people that were in a military postgraduate school. So one thing they ask is, like, are there limits to how smart us could get? So, you know, or could these things get kind of arbitrarily smart? You know, to which, I mean, that's a good question, because, I mean, if there are sort of intrinsic limits, then maybe they don't ever reach a super intelligence level, but I'm unaware right now of the source of any such limit. So I won't say they don't exist. I'm just unaware of any such limit. There are arguments that there's only so much material available to be learned off of. So, you know, once you've read the entire internet, you know, maybe training materials will be harder to come by and stuff. But and that doesn't really hold up too much if you push on it. So, what else? Gosh, actually, Jorge's on here. Do you remember what the other questions were? He was there.
Yeah, I remember just a few questions in the military school. Colonels and captains of the Navy, they were non-military, as far as I remember, non-military questions.
Mhm. Yeah, they were generally actions. They weren't like about military applications or anything. They were kind of the same kind of questions I'd expect you guys to ask, you know. So yeah, just there were a few. I just don't remember what other ones there were right now. But all right. Any other questions? Oh, here's one. Oh, okay, that's the same one. All right. Well, good. Well, let me thank everybody for attending. Hope you got something out of this and enjoyed it. So again, as I mentioned, you'll see some miscellaneous topics of AI coming out on our social media if you're interested in that kind of thing each week now for a while. So tune into that, and we'll talk to you later.